Okay, I'm going to show you guys how to use the tooling probe, which is that guy right there, right in the back left-hand corner. And you can see right there on the end, there's a little post sticking up. That's what you're going to touch down. We're going to do the 3/8 end mill, and we're going to touch down on that, and we're going to find our tooling Z offset. First thing we're going to want to do is we're going to press the input button right here. It brings up a whole new different page. So we're going to go to part setup, go to tool setup. Alright, we're going to begin setting up our 3/8 end mill that's in the spindle right now. I'm going to go ahead, it's tool number 3. So 3 and then enter. It says it's in the spindle, so that's good. Enter our diameter. Enter on this keypad here, 0.375. Enter. The tool type, we're going to select end mill. From here we can give it some more measurements, but for right now I'm just going to focus on probing the tool. So we go to more, we'll go to tool probing. This value right here is the absolutely most important critical measurement you can do on this page. And it's very important that you grab a tape measure, and right here, and what it tells you right here, an estimated tool length before probing the tool. So, open up the door, get the tape measure out, you go directly from the bottom of the spindle and you eyeball where the bottom of the end mill is. It reads about 4 1/8, but what I've been told is that when you want to be wrong, you be long. So we're going to enter 4.25, so 4 1/4. Okay, so the other stuff on this page, the rapid clearance usually populates automatically. What happens is this is the length it gets to before it goes from the fast speed. So your Z-axis is going to rapid down at your fast speed, and then it's going to get to your slow speed at this rapid clearance length, and then go to your slow speed. So let's just put 20 in as a general number for the rapid, and the slow we'll put in as 5. Minimum length delta, what that does is it gives it a safe clearance after, say if it didn't hit it. So we'll just give it a 1/2 inch. From here, your spindle usage, since this is an end mill, we want to go in a counterclockwise manner, since our cutting happens when we go clockwise into a part, specifically with this end mill. We want to go counterclockwise so we don't cut into our little probe on the end there. So you do want to spin the spindle while you're probing. We give it 1,000 ripams. From here, we're check everything, make sure everything's good to go, and then you can start probing. We're ready to probe. You'll press this probe current tool now, and you press the start cycle. And you'll notice that I just pressed the feed hold. It's a really handy button to have if you're like a little worried you're going to crash something. I've already done this, so I'm pretty confident that it's going to work again. So I'm going to go ahead and press this button. And here it goes. Rapids down, and then it just starts touching off on it. It bounces down on there about 3 or 4 times, and then comes back up. And then you'll come over here to your page, and you'll notice that the tool calibration length changed to 4.169. There you go. Also, when setting up a tool, it's important to note the size of this little thing that you touch down on. It's pretty small, and what happens is you don't want to touch down at it right on the center of the end mill. That's let's say this bed mamma jamma right over here. You may want to do something called a tool offset. So you don't want to touch down right in the center just in case, you know, you don't want to blow this thing up if you have an error. So what you're going to do is you're going to go to tool offset, and you're going to offset this length on your x-axis, so it's going to move it, you know, it's going to move the tool over this way slightly when it goes to touch down onto it. To reiterate my last point, you'll notice that, you know, it's kind of honed out here in the center, right? So you do want to do a tool offset, and always make sure to go in a counterclockwise manner, because you can see if you were to go clockwise, you risk running one of these teeth directly into that probe I was showing you. So always go counterclockwise, unless for some reason you're milling in a counterclockwise direction, then you would need to go clockwise. If that makes sense. Another feature that could be handy for us, the setup guide told us that it's not necessarily needed. It's easier to you know, use a micrometer on the diameter of the tool. So if you're doing very precision stuff, you want to take your micrometer and actually get the diameter of the tool to make sure it's, you know, it's actually 3/8 of an inch kind of thing. But if you did want to get the diameter of the tool, you would select diameter, and then you would it could touch off on these sides of it and understand what the actual diameter is of the tool, but it's not necessary.